During the Mesozoic era, roughly 250 to 66 million years ago, Earth's oceans were some of the most dangerous ecosystems ever to exist. Unlike today's seas, which are mostly dominated by relatively small predators and well-studied ecosystems, prehistoric oceans were vast, largely unexplored, and home to creatures that could grow to sizes impossible by modern standards. The marine environment was a constant battleground, where survival depended on speed, strength, and evolutionary specialization. The supercontinent Pangaea had already formed, merging most of the Earth's land masses into a single enormous landmass. Its assembly reshaped global ocean circulation, creating massive oceans and shallow epicontinental seas along its edges. Panthalassa, the superocean surrounding Pangaea, covered most of the planet and was the stage for the evolution of the first true oceanic giants. Closer to the equator, shallow warm seas such as the Tethys Ocean provided nutrient-rich habitats that supported high densities of marine life, from small invertebrates to large predators. Early in the Mesozoic, marine reptiles began to dominate. Ichthyosaurs were among the first to evolve streamlined, fish-like bodies suited for fast swimming and long-distance hunting. Some species, like Shawnosaurus, could exceed 20 meters in length, preying on fish, cephalopods, and smaller marine reptiles. They relied on speed and acute vision to locate and capture prey, a strategy that allowed them to dominate the open water. At the same time, plesiosaurs emerged as another group of powerful predators. These reptiles had long necks and small heads in some species, adapted for snapping up agile prey such as ammonites, or short, robust heads in pliosaurids, designed for crushing bones and shells. Liopleurodon, a plesiosaur, could reach lengths of up to 7 to 10 meters, and is estimated to have had one of the most powerful bites among marine reptiles of its time. Its combination of speed, strength, and sensory acuity allowed it to ambush prey with lethal efficiency. Predatory fish also flourished. Dunkleosteus, a massive armored placoderm, could grow over 10 meters long. It had powerful jaw plates capable of slicing through thick armor and bone, making it a top predator in late Devonian and early Mesozoic waters. Alongside it, other early sharks, such as Hybidus, patrolled shallow seas, hunting smaller fish and invertebrates while avoiding larger predators. These predators created an environment where only the fastest, most agile, or most heavily armored animals could survive. The oceans were also filled with smaller but abundant life forms that shaped predator behavior. Ammonites, coiled-shelled cephalopods, provided a key food source for many predators, while schools of fish developed complex schooling behaviors to reduce the chance of being singled out. Marine turtles, early rays, and crustaceans contributed to a diverse food web, all living under constant pressure from the top predators. Environmental factors increased the ocean's danger. Strong currents, tidal shifts caused by the moon's closer orbit, and varying oxygen levels in deep water created zones that were difficult or deadly for unadapted creatures. Predators exploited these environmental pressures, learning to ambush prey in shallow waters, strike from the dark depths, or chase targets across long distances in open water. By the late Jurassic, these ecosystems had reached remarkable complexity. Apex predators such as Kronosaurus and large pliosaurs dominated the seas, while ichthyosaurs, smaller plesiosaurs, and early sharks filled specialized hunting niches. The balance of predator and prey was maintained by continuous evolutionary pressure, resulting in an ocean that was both richly diverse and lethally efficient. By the late Cretaceous, the oceans had evolved into some of the most formidable ecosystems in Earth's history. Predator size and specialization had reached extremes, with creatures developing not only immense strength, but also sophisticated hunting strategies. These waters were dominated by mosasaurs, giant pliosaurs, ichthyosaurs, and enormous predatory fish, each occupying distinct ecological niches. Mosasaurus hoffmanni, one of the largest mosasaurs, could reach lengths of over 15 meters. Its body was long and flexible, with powerful tail fins that allowed bursts of speed to chase schools of fish or smaller marine reptiles. Fossilized stomach contents reveal that mosasaurs could prey on turtles, ammonites, and even smaller mosasaurs, demonstrating their role as apex predators. Their teeth were conical and slightly curved, ideal for holding slippery prey, while their jaws exerted enough force to crush shells and bones. In parallel, pliosaurs such as Kronosaurus continued to dominate shallow seas. Measuring up to 12 meters, Kronosaurus combined speed, size, and powerful jaws to feed on other marine reptiles and large fish. Its skull structure suggests it could generate immense bite forces, while its body proportions indicate bursts of rapid acceleration for ambush attacks. These predators were particularly effective in reef environments, where maneuverability and sudden strikes gave them an advantage over smaller, more agile prey. The ichthyosaurs, though declining in diversity by the late Cretaceous, remained critical components of the ecosystem. Shawnosaurus and similar species occupied deep water habitats, hunting soft-bodied cephalopods and smaller fish. Their streamlined bodies allowed them to cover long distances efficiently, while large eyes adapted to low-light conditions made them capable deep-water hunters. Predatory fish also also escalated in size and specialization. Xiphectinus, a giant bony fish reaching up to 6 meters, was capable of swallowing smaller fish whole. Its elongated body and sharp teeth made it an efficient predator in open water, and fossilized stomach contents often preserve intact prey, showing how voracious it was. Smaller fish and early sharks continued to occupy mid-tier predatory niches, navigating the constant threat of the larger reptiles and predatory bony fish. Even without the massive apex predators, the prehistoric oceans were far from safe. The Mesozoic seas were a realm of constant peril, where every swim, hunt, or drift carried risk. Danger was woven into every level of the ecosystem, from the smallest plankton to mid-sized predators, and even the terrain itself. One of the most striking sources of danger came from ammonites. These coiled-shelled cephalopods were abundant in shallow and mid-depth waters. Their hard, sometimes spiny shells made them difficult to attack, capable of injuring predators that tried to bite or swallow them. Ammonites were not passive. Many species could withdraw quickly into their shells, and their sheer numbers created a labyrinth of obstacles for both predators and prey navigating reefs or shallow seas. Their tentacles also allowed rapid strikes on small fish or invertebrates, adding an unexpected layer of risk for smaller hunters. Schooling fish, though appearing harmless, created hazards of their own. Massive schools could disorient predators, but the chaotic movement sometimes led to collisions and injuries for less agile swimmers. For prey species, staying outside a school increased exposure to mid-tier predators, while entering one meant navigating a constantly shifting swarm where even a single misstep could lead to death. Cephalopods like early squid and belemnites were both prey and deadly opponents. Many could jet propel with bursts of speed, evading capture while simultaneously striking with tentacles to injure or stun smaller fish. Some species developed sharp hooks on their tentacles, making even a brief encounter with them potentially fatal for smaller hunters. These ambush specialists added a hidden layer of danger in reef environments and open waters alike. The seas were also populated by early turtles and armored fish that survived by relying on defensive adaptations. While they were primarily prey, their hard shells and spiny defenses could injure attackers. Even mid-sized predators had to navigate cautiously. A miscalculated strike against a spiny turtle or armored fish could result in injury or death, creating a perilous environment where survival required constant vigilance. Invertebrates contributed to the ocean's lethal complexity. Early jellyfish and comb jellies, though small, were potentially venomous and could immobilize tiny prey or even damage delicate gill structures of fish. Swarms of crustaceans and mollusks not only provided food for predators but also created dense obstacles, forcing hunters to maneuver carefully or risk injury. Environmental hazards intensified the danger. Shallow reefs, while providing shelter, were full of crevices and overhangs that could trap or injure unwary swimmers. Strong currents and tidal shifts in epicontinental seas meant that a slow or weak swimmer could be swept into deeper waters or against sharp rocks. Oxygen minimum zones in deeper waters created areas where only specialized predators could survive, while sudden temperature fluctuations near the surface forced rapid adaptation. Even seemingly calm, open water held threats. Sudden storms, waves, and turbulent currents could separate prey from protective groups, making them easy targets for ambushing predators. Deep water zones, often dimly lit, allowed smaller predators to hide and strike unexpectedly, turning every journey through the ocean into a calculated risk. The danger of the prehistoric ocean was not only in its predators or aggressive prey. The environment itself was a relentless threat. Ocean conditions during the Mesozoic and Cenozoic created challenges that could kill even the most well-adapted swimmers. Currents, tides, temperature gradients, oxygen levels, and underwater terrain all combined to make survival a constant test of skill, speed, and endurance. Ocean currents were among the most significant hazards. The superocean Panthalassa and epicontinental seas of the Mesozoic generated strong currents, particularly around shallow continental shelves and reef edges. Creatures caught unaware could be swept into deeper waters, away from safety, or into areas populated by ambush predators. For smaller fish, turtles, or squid, even a brief loss of control meant a sudden confrontation with a predator, turning ordinary swimming into a fight for survival. Tidal variations also shaped the danger zones. Shallow seas experienced dramatic fluctuations, exposing reefs and sandbanks at low tide, while creating turbulent waters at high tide. Prey trapped near the surface or in tidal channels could be isolated, making them easy targets for mid-sized predators. Ambush hunters exploited these zones, waiting for the chaos of tides to strike. Temperature gradients added another layer of risk. During the Mesozoic, equatorial waters were much warmer than today, but polar and deep water zones remained cooler. Rapid vertical movements between layers of different temperatures could disorient creatures, affect their metabolism, or slow their reaction times. Predators and prey alike had to navigate carefully, as a sudden plunge into a colder zone zone could reduce speed and make escape impossible. Oxygen levels were unevenly distributed, particularly in deep or stagnant waters. Low oxygen zones, sometimes called hypoxic areas, could kill or weaken unsuspecting creatures. Only species adapted to these conditions could survive, creating pockets of deadly terrain where any miscalculation meant suffocation or death. Some ambush predators learned to exploit these zones, hunting weakened prey in oxygen-poor depths. Underwater terrain, reefs, rocky outcrops, and deep trenches further amplified the danger. Shallow reefs offered shelter but also concealed predators waiting to strike. Narrow crevices could trap or injure small fish or squid, while steep drop-offs could sweep creatures into abyssal depths. Open sandy flats, though appearing safe, often left swimmers exposed to large hunting predators, while currents could quickly transport them into reef hazards or ambush zones. Throughout the Mesozoic and into the Cenozoic, the oceans were shaped by constant evolutionary pressure. Survival depended not only on avoiding apex predators or environmental hazards, but also on navigating the complex interactions among prey, smaller predators, and competitors. Every adaptation carried a direct impact on survival, reinforcing the oceans as one of the deadliest places on Earth. The oceans were also punctuated by periodic extinction events that further intensified danger. The KPG extinction wiped out non-avian dinosaurs, some marine reptiles, and numerous invertebrates, creating temporary vacuums in the food web. Opportunistic species such as early sharks and teleost fish expanded rapidly, but the ocean remained perilous. Shifts in sea levels, temperature fluctuations, and changing currents created new hazards for all marine life, ensuring that survival remained a matter of adaptation and timing. Predator-prey dynamics continued to escalate. As prey evolved agility, schooling, armor, and venom, predators responded with size increases, faster bursts of speed, and specialized hunting techniques. Deepwater ambushes, nighttime hunting, and cooperative strategies evolved in tandem with environmental pressures. Even minor predators could be dangerous under the right conditions. By the Cenozoic, the oceans were populated by species such as early whales, giant sharks, and large predatory fish, each navigating a world where danger was omnipresent. Megalodon's eventual dominance represented the culmination of millions of years of evolutionary trial by fire. Its massive jaws and serrated teeth symbolized the apex of adaptation in a system where only the strongest, fastest, or most cunning survived. Yet even these giants were vulnerable to environmental hazards, prey defenses, and competition from other predators. In this way, the prehistoric ocean maintained its reputation as a realm of danger. It was a place where life was shaped by constant threats. From the smallest cephalopod to the largest apex predator, every creature in these waters contributed to an ecosystem in which the ocean itself was as deadly as any hunting animal.